Hello student. Today's topic is GSM system. Comparison of the characteristics of the cellular network communication system in that first generation, second generation, fourth generation. In that the year of introducing first generation is 1980. 1993 the second generation. Third generation will be developed 2001 and the fourth generation of the mobile will be evolved in 2009. Then technology use in first generation there is an advanced phone mobile phone technology is used. In second generation is95 GSM. Then in the 3G third generation mobile IMT 2000 and WCDMA is the technology used, whereas in 4G most popular LTE and the WiMAX this technology is used. Multiple address and access system. In first generation there is FDMA, second generation is FDMA, TDMA, third generation we are using the CDMA, fourth also we are using the FDMA. Speed of the data is 2.4 to 14.4 kbps in the first generation, second generation is 14.4 kbps, third is 3.1 mbps and fourth generation is 100 mbps. The special characteristics: first, it is the first wireless communication. Digital wireless technology is to be used in the second generation, and then digital broadcasting is available. High speed data is available in the fourth generation. Features: only voice transmission will be possible in the first generation. Then multiple users in the single channel can be used. Then features of third generation is multimedia features, video call. This facility is available in the third generation, whereas in the fourth is a high speed real time streaming. Bandwidth analog 50 megahertz, 50 megahertz and 100 megahertz. Okay, what is GSM? GSM stands for Global System for Mobile Communication. It is a digital cellular technology used for the transmitting mobile voice and the data services. There are the three different services used in the GSM GSM services, that is a barrier services, teleservices, supplementary services. First one is a barrier services. Barrier services is called as a data services. These are the technological services provided the capacity of the transmitting of the signal between the access point. Means it is mostly used for the data services. Then teleservices. Teleservices is nothing but the transferring the voice call between the system. So these can be possible with the help of teleservices. The example of teleservices is fax, voicemail, mobile voice communication, emergency number, and non-voice teleservices are SMS, email. Okay, then after that there is the supplementary services. Supplementary services include call waiting, that is notification of the incoming call. Call hold means put the caller on the hold to take the another call. Call barrier, all calls, outgoing calls, incoming calls are to be barriered. Then call forwarding, call can be sent to various numbers defined by the users. Then multi uh, partly conferencing, that is there is a multiple callers can connect together. These are the GSM services available. Then this is the system of GSM architecture. In GSM architecture there are three there are three subsystems. These are BSS, network switching subsystem, and operational support subsystem. Base station network and public switching subsystem. Okay. So in this one, first is a mobile equipment, mobile station. So mobile station are made up of two entities. That is the mobile equipment. It is the portable device. It has a unique identifier number, that is IMEI number. It is used for voice and data transmission. Then Then it also consists of subscriber identity module. That is the smart card that contain the international mobile subscriber identity, that is IMSI number. It allow the user to send and receive the call and receive other subscriber services. Then then there is a BSS. BSS means base station subsystem. The base station subsystem consists of BTS and BSCs. So base station subsystem, it is also known as a radio subsystem, provide and manage the radio transmission between the mobile station and the mobile switching center. BSS also manage the interface between the mobile station and all other subsystem. The GSM is consist of two part, that is base trans receivers station and BSCs. So, so base transceiver station, it encodes, encrypt, multiplex, demodulates, and feed the RF signal to the antenna. It consists of the transceiver unit. It communicates with the mobile station via radio air interface, and also communicate with the BSC via ABIS interface. Then next, BSS is comes next part is base station controller. It manage radio resources of the BTS, is assigned frequency and the time slot for all the mobile station in the area. It handles call setup, transcoding, and adaptation functionalities. Hand over to each mobile radio power control. It communicated with the MSCs via the A interface and also with BTS. Then there is a next subsystem is network switching subsystem, that is NSS. It manages the switching operation of the system and allow the MSCs to communicate with the PSTN, ISDN and data services. So first one is a mobile switching center. Mobile switching center, it is the heart of the system, is manage the communication between the GSM and the other network. It manages call setup functions, routing and basic switching. It performs mobility management including registration, location upgradation and inter BSS and inter MSCs call handoff. It provide billing information. MSC does gateway function while it customers roams to other network by using the HLR VLR. Okay. Then in the network switching there is a HLR. HLR means home location register. It is a permanent database which about the mobile subscriber in a large service area. It database contain MISI number, prepaid postpaid information, all the supplementary services. Then next one is a VLR, visitor location register. It is a temporary database which update whenever new mobile enters into the area by HLR database. It it control mobile roaming in this area. It reduce the number of queries to HLR. Then there is a AUC, that is authentication center. It provide the protection against the untrusted of air interface. It maintain the authentication keys and algorithm that provide the security. After that there is a equipment identity. ERE is also consist of in MSCs. It It is the database that is used to track the handset using the EMEI number. It made up of three subclasses: whitelist, blacklist, and the gray list. And operational subsystem is provide the maintenance of the subsystems. And after that, the MSC is also is also connected to the PSTN, ISTN, and data services to transmit the signal. Now, interface used in the GSM network. In this diagram, the ABIS interface is used between the BSCs and BTS. Then air interface is used between the mobile station and the BTS, because through the air it is connected to the base station and BTS. Then A interface is used between the BSCs and MSC, and signaling protocol SS7 is used between the BSCs and other network. Okay. Okay. Then GSM security and encryption. GSM is the most secured cellular telecommunication system available today. GSM has its own security methods standardized. GSM maintains end-to-end security by retaining the confidentiality of sales and GSM subscriber. Then temporary identification numbers are assigned to the subscriber number to maintain the uh, privacy of the user, because it means, as we are using the another number of the mobile users, so that there is it maintain the security, it maintain the privacy of the user. The privacy of the communication is maintained by applying the encryption algorithm. Then then mobile station authentication. GSM network authentication identities of the subscriber through the uses of challenge response mechanism. A 128-bit random number, that is RAND number, is sent to the mobile station. The mobile computes the 32-bit signaling response based on the encryption of the bit random number with the authentication algorithm using the individual subscriber authentication key. Upon receiving the signaling response from the subscriber, the GSM network repeats the calculation to verify and identify the subscriber. The the individual subscriber uh, authentication key is never transmitted over the radio channel. It is present in the subscriber SIM, and as well as authentication, home location register, visitor visitor location register database. If the receiver agree with the calculated value, then MSC has been successfully authenticated and may continue. If the value do not match, then connection is terminated. Otherwise, the authentication fails indicates to the mobile. Then signaling and the data con- confidentiality. The the SIM contain the ciphering key generate algorithm. It is one of the algorithm to secure our key. This is used to provide the 64 ciphering key, and this key is computed by applying the same s- random number used in the authentication process to cipher the generating algorithm, which is individual subscriber identity key. The GSM provides the additional level of security by having the way of changing the ciphering key, making the system more resistant to eavesdropping. The key may be changed at the regular interval as required. This is all about the GSM, its security, and all the things related to this one. Thank you.